What is the answer? This is the total area, positive minus negative. Check it. What is the answer?
2.46.
2.46 kilonewton. Is it the same in your book?
Yes.
Yes. It's done. Next we have to talk about the influence line diagram for a girder. Okay? Let me erase all these things.
Just one thing.
Yeah, 6.3, because of short of the time, I'm not going to cover this topic because I think the influence line diagram for girder and for truss is more important than this topic. Alright, because how many lectures we are left with? Just 6 after this class?
Week.
6.
6, yes.
So we have to cover the reflections as well.
13, 14, 15.
Include the 15th week as well, okay? Okay, next. Next is solid place, the influence line diagram in girders. It's very simple, no new thing, same concept, same procedure, but now your load is acting like this. For example, if you see this load, for example, if this load is on panel AB. So when the load is on panel AB, so the reaction will be transferred from this point and this point. So the load is actually coming from point A to point B. Similarly, when the load is at panel BC, so the load on this beam, we have two beams. One are the small beams which are resting, for example, on the bigger beam. So actually we have to draw the influence line diagram for this bigger beam. We call it girder as well. Girder is a bigger beam that carries the small beams. Okay. So that load, it will be transferred by a reaction at this point and at this point. So this reaction depends upon the location of this load. If this load moves on point BC, the load on this bigger girder will also change. Do you understand? It's easier. It's not complicated. Don't worry. The reaction at point B and at point C is actually the load on bigger beam B and C. That's all. Let's solve one example which is in your book. Yeah, let's solve example 6.13. Let's solve one example. Actually, I converted the units, Okay, I just put it here. 3. I will send you the lecture notes till today.
And that's part of our exam, right?
Yeah, this up to today's class is included in your exam. I told you this before, and I also gave you some examples. Listen please. After this we have to study deflection. Okay? So for deflection we will study 2 to 3 methods to calculate the deflection. Maybe we will not go for the full chapters, but at least we will select some useful topics which you can use for the deflection calculations. Okay, so this is a girder, and what is the question? Anyone can read it for me?
Yes, draw.
Yes. Yes, draw it.
Draw the influence line for the shear.
Read it. Sorry.
Draw the influence line for the shear imbalance CD of the greater and bigger.
So, what is the question? We have to draw the influence line diagram for panel CD. Shear, we have to draw the influence line diagram for shear for panel CD. In case of girder, the shear between C and D, it is changing or will remain constant? Okay, first complete your question. Okay, so we have to draw the influence line diagram for panel CD. So what we will do, we will put the load at point A, and at point B, at point C, and at point D, and at point E, and we will find out the shear at point C. Okay? So let's do it. So when the load is at point A, I don't want to use thick marker because it will, this is B, RB. So when load is at point A, when x is 0, how much will be RB? When x is 0, it will be on A. How much will be RB? Or sorry, how much will be RG, I should say. RG. When the load is at point A, x is 0, how much will be RG?
It will be the same.
1 multiplied by 12 minus.
You want to write equation or just you want to direct calculate?
No, question.
Questions, please.
Easier.
Yeah.
So it will be the same equation which we drawn before.
Yes.
Just distances will change. Instead of 4 over 3, it will be 12 over 9. And it will become same. Yes, it will become same.
12 over 9.
It will be, if you want to write the equation will be 1 minus 4 over
X.
So when x is 0, how much is RG?
That's one, yeah.
No.
Next is
Maybe I think 4 over 3 is outside of the equation, just make sure.
it was 1 over 3.
Where is the equation? Which we write before.
It was 1 over 3 multiplied with 4 minus 6.
You need the first.
The last example.
Here, the last example. The last example we had 1 over 3. So in this case it will be 1 over 9 into
12 minus 6.
minus x. So if x is 0, how much will be RG?
4 over 3.
12 over 9.
4 over 3.
1.33.
Yeah.
Yeah, that was the same.
And how much will be shear at point C? How much will be shear at point C? If the load is at point A, the The load here is 1 kilonewton, 1, whatever.
1 minus RG.
And the reaction here is 1.33. How much will be VC?
0.33.
Minus 0.33.
Minus or plus? Check it.
Should be minus against RG.
It should be plus or minus.
Direct, what the direction?
I need the answer from you.
It must make it positive moment, so
اتجاه اليسار لأعلى. Minus.
minus.
Minus 0.2.
If the load is here, so it means the upward shear is 1.33 and the downward is minus. So it should be plus 0.33.
Is it going downwards or upwards? Down.
We have the downward shear, the positive one. Let me see in your book.
Yeah, so it can rotate.
Yes, it's positive. Yeah. So when the load is here,
أنا هركب ده.
so here I'm going to draw the influence line diagram. See, reaction positive upward, load negative downward. What is the result?
0.3.
Positive upwards.
Plus P is equal to 0.
Just
So,
check my lectures. Please check my lectures in which I have explained the shear force. So here I am going to draw the ILB for shear. It is positive. Okay, so it is 0.33 here. When x is 0, how much is the shear at point C? In panel CD. 0.33. So just make a point here, 0.33. And when x is here, x is 3 meter and the load is here, 0. How much will be the, when x is 3, how much will be RG? 1. And how much will be VC? 0. And when, now the load is moving next. Now the load is on panel BC. Okay? So if the load is on panel BC, or the load is at point C, X will be 6. RG will be half.
No.
6 over 9.
6 over 9, that's
0.3.
2 over 3. So 0.67.
0.67.
2/3.
Yeah. 0.67. 6. It is 0 when the second point and the third point.
Minus 0.33.
When x is 6.
Yes.
So when x is 6, RG is. Please check. When x is 6, how much will be RG? Please check this.
6 over 9.
6 over 9.
6 over 9. It is
2
how
over
much?
3. 2 over 3. 2 over 3.
So 0.67.
0.67. And how much will be VC? 1 minus 0.32. So here you have shear minus. And now what about point D? When the load is at point, so this point you have minus 0.33. 3, 3. And now when the load is at point D, what will happen?
A would be
RG 0.33.
1/3. So -1 plus 0.33. It would be minus 0.67.
Now here we have the important point. If the load is on panel at point D, the reaction at point C will be 0. The reaction at point, because
We're taking section.
yeah, listen, when we talk about this, when you will take a section here in the panel CD and the load is at point D, you are considering the left section.
Yeah.
So it means that there is no load.
Yes, there is no.
And BC is equal to reaction. Okay, hold on. When X is 9, how much will be RG?
3 for 9.
0.33.
1 over 3.
Now the load is at point D, but we are considering our section left side. So it means that the load is not in our section.
Yeah.
So BC will be equal to
RG.
RG, or 0 minus RG minus 0. So it is 0 point
Positive or negative?
positive. And when the load is at point E, how much will be the shear?
0.
There is no difference in the beam or girder. The only thing is that in girder the load is transferred from panel point. That's all. So this will be the interest line diagram. Please raise your hand if you do not understand. You do not understand?
Yes. Just one thing. Just the VCD. Sometimes it's negative. Positive. That's it.
Okay,
That's my question.
For the
PC.
PC.
I mean, I do it from, just forget about all the beams at the top, forget about that.
Yeah.
Alright.
Okay, just consider when the load is at point A,
Alright.
when the load is at point A, how much is
RG.
X? X is 0
Yeah.
and RG is
1.
1.33.
1.33. And I need the shear here at point C.
Alright.
So what will be the sections? Let's do it. I mean, if you are confused,
Downwards one.
here you have, it's the same panel. The load is here, the load is 1 and the reaction is here.
1.3.
And we need shear at this point. And this is VC positive. This is the positive shear. So apply the equilibrium.
If we consider PZ to the abort, it will be
No,
9.
you should, if you consider the section from right, then you should consider positive upward. I told you that. So VC is equal to, this is the diagram. Now if your load is here, if the load is here, X is equal to 3, how much will be this reaction?
1.
1. And how much will be VC? 0.
1 minus 1.
If the load is, if X is 6, or if X is 3 meter, X is 3. It means your load is now at this point.
Yes.
How much will be the reaction?
1.
1 equals.
And 1 is also
And how much will be VC?
0.
0. So 0. Now if your load is at point C, if your load is now or x is equal to 6, how much will be RG?
0.67.
0.67. I just consider the load. This is now 0 point, and the load is here. -1 plus 0.67. How much will be VC?
-3.
minus 0.33. And when the load is at point D, now this load is no more in picture. When the load is at point D, how much will be the reaction? 0.33. And how much will be VC?
Same.
But positive.
Yes.
So you have positive 0.33. And when the load is here, how much will be this reaction? 0. And how much will be VC? 0. Load, you are considering a section, this section.
Okay.
The load is not on this section. The load is here at point E. How much will be VC?
So
The reaction will be 0
At
and
point-
VC will be
At the point D and A, we have considered only the reaction.
yes. At point D and E, you will only consider reaction because load has gone. Do you understand?
Yeah.
Yes, right.
How many of you still do not understand? Please raise your hand. Please raise your hand. There will be a question in your exam from this influence line diagram. I'm worried about you. Okay? Now, the same thing, the same way you can do for the moment. So, how much is time?
10 minutes.
10 minutes. We did not hear the
Yeah.
today. Okay, so
Maybe he has a.
we have 15 minutes now. From the I think from the slide I explained from the slide I should explain you the last or this question. So what is this question? Any one of you can read?
Draw the influence line diagram about the moment at point F.
So you need the moment at point. You have to draw the influence line diagram for the moment at point F. Okay. Yes, that's only?
Yes.
It's very simple. Forget about the girders. They make you confused. Put load at point A. How much will be the reaction at point H? If you put, now please see, the load is on the girder. So if the load is on point A, so how much will be the reaction at point H?
0.
No. See here, now I tell you. If the load is here. Okay. So the load is here, and this load is 1. Okay. So how much will be the
1,
It will get transferred to B.
2B.
And then from B, you'll see the reaction at H.
if the load is here at point A, so the reaction at point H will be how much? How much will be the reaction? How much will be the reaction here at point B?
1.
No,
0.
0.
Yeah.
If the load is at point, the unit load is here, this load is 1. So all the load will directly go on to this support here.
Yes.
So the reaction at this point will be 0, and this reaction will be
0.
0.
Connected to A.
Because there is no load. So if this reaction is 0, how much will be the moment at this point? It will be 0. 0. Now please see this table. If x is 0, mf is 0, I write it here. Rf will also be 0. Or Rx, sorry. Now put the load at point B. Now the load is moved from this point to, and this load is 1. This load is 1.
The reaction H will be.
How much will be the reaction?
1.
No.
No. You will have to do the.
Now the load is at point B. How much will be the reaction? Now the load is at point P. How much will be the reaction at point H? It's just like simply spotted beam. The load at point B. No more complication.
0.5.
0.86.
So get ready. I think you are not.
Teacher, we are not reviewing anything. This week I had 4 midterms. Other students had
It
5.
seems you forget how to calculate reaction, shear force, bending moment, or you have just deleted everything.
Because the stress of the method.
Can you turn on that? Use this if you want.
Then I got them all. Doesn't it?
Okay,
خليك عندك.
leave it. So these are your girders. Can you press? Because it will reduce my work. Take it easy. It's very simple. No complication. Forget about the girder at the top and just put the load and see what happens. Calculate the reaction and calculate the moment at point D. For example, now the load is at point B. The load is unit. How much will be this reaction? Just take moment at point H.